Okay, so sorry for this really weird setup, but I'm just gonna kind of give you a guideline of how you are going to do input and output boxes with fractions and decimals. It is the exact same as if you were to do it with normal numbers. So up here, I just have a normal input-output table. It can be faced either this way or like this. It does not matter as long as you're aware of the in section and the out section and what area you will need. So with the input and output table for the first one, this is, again, just an example to show. So the first numbers that we're going from is from 7 to 14. So there's two ways to get from 7 to 14. We have plus 7, and we also have times 2. So we're going to keep those two in mind as we move on to the next one. We're going from 14 to 21. So if we were doing times 2, then that would be 28. So we can automatically just knock out that times 2. So let's see, does plus 7 work? So we have 14, 15, 16, 17, 18, 19, 20, 21. Yeah, it does. So we know that our rule is going to be plus 7. So when we're going from 21, and we need to find out what goes in this output box, we're going to use our rule of plus 7. So it's going to be 21 plus 7 will equal our output box. And I know you guys know this, it is 28. So 28 is what goes into that box. So now we're moving on to something a little bit more difficult. It's just with decimals. So with the decimals, you have to find out what your rule is. Just like we did up here, how we knew that it was plus 7. So we need to find out how we got from 0.35 hundredths to 0 and 45 hundredths. So this is the first example that is on your decimal sheet that you were going to work on. So I wanted to give you guys that example as the practice. So we're going from 0 and 35 hundredths to 0 and 45 hundredths. So the way that I like to do it is I'll just take it and I'll go, okay, so we have 0 and 45 as our output. I am going from the output to the input to find out the distance just because the output is bigger. And maybe I don't know how to get from there to here. So I'm just going to flip it. And I'm going to minus 0 and 35 hundredths. So 5 minus 5 is 0. 4 minus 3 is 1. 0. So the distance between 0 and 35 hundredths and 0 and 45 hundredths is 0 and 1/10 or 0 and 10 hundredths, however you would like to read this. So this is what we maybe our rule, but we have to check. So a way we can check is by moving on to the 0 and 45 hundredths, and we need to get to 0 and 55 hundredths. So if this is what our rule is expected to be, you can either see by doing the exact same thing, subtracting 0 and 45 hundredths from 0 and 55 hundredths, or you can take that 0 and 45 hundredths and add that 0 and 10 hundredths to see if it would equal that output. So if we add them together, then we know that it does equal that. Just to be safe, always check. So let's see. To get from 0 and 55 hundredths to 0 and 65 hundredths, 0, 55 hundredths plus 0 and, not 65, plus 0 and 10 hundredths, 5, 6.0. Yep. So it matches. So we know that our rule is plus 0 and 1/10, which would be written like this, or 0 and 10 hundredths, which would just be adding that 0. So now we can take our number, because we still need to find out what goes in this box. So now we have 0 and 65 hundredths plus 0 and 10 hundredths. 5 plus 0 is 5, 6 plus 1, 7. This is what will go in the box. 0 and 75 5/100ths. So let's say on this, it goes from a bigger number to a smaller number. Then you're going to do the exact same thing, but instead of subtracting the output from the input, you can just subtract, or the input from the output, you can just subtract the output from the input. Just make it easier on yourself, figure out the easiest way for you, and make it work. So now we're on to the fractions. So this is a separate worksheet. If you would like to pause this video and come back after you finish the decimal worksheet, then you may. But this is the first table on the fractions worksheet. So our input and output, we go from 1/2 to 2/2, or what would be 1/2. In this case, that instance doesn't matter. It might, in some cases, they might say, like down here, there's 4/2. It could be 1 and, or I'll use the 5/2. It could be 2 and 1/2, and then you'd have to know that that is the same as 5/2. But in this case, it doesn't matter. So we're trying to figure out how to get from 1/2 to 2/2. So you would just do the exact same thing. So you're gonna do 2/2 minus 1/2, and we already know the denominators are the same. We don't have to touch that. So we just do 2 minus 1, which is 1/2. So to get from 1/2 to 2/2 is adding 1/2. But let's see, does that work with all of them? So now we're trying to get from 3/2 to 4/2. So we're gonna do 3/2 plus that 1/2 that we are suspected to see. And we have the same denominator, so it stays a 2. 3 plus 1, 4. So it does work. Again, if you are unsure if it is going to work, then you will need to continue to do the way you do with the first one. So instead of doing the plus 1/2, you would still do the 4/2 minus 3/2, which would still be 1/2. But because I know that, I'm just going to continue with this method. So we have 4/2 plus 1/2, which is 4 plus 1, 5/2. Now we need to find out what goes, I forgot the little arrow. Now we need to find out what goes into, or what 6/2 plus 1/2 is. So we know that plus works, it works, and it works. So now we know our rule is going to be plus 1/2. So we have 6/2. So I'll use a different color just to make it pop a little bit better. 6/2 plus our rule, which is 1/2. We know our denominator is going to stay the same. Now we do 6 plus 1, which is 7. So it would be 7/2. And then our next one, 7/2 plus 1/2. Again, the denominators are the same. Don't have to touch it. Then 7 plus 1, which is 8. So it would be 8/2. Hopefully that makes sense. If not, then we will continue working on this when I get back on Thursday. I'm so sorry for the inconvenience of me not being there. Hopefully these lessons are a little bit clearer than last time when I was sick. So I hope this helps.